Next up, Marcel Fest. He will talk about running a platform for container-based network functions in 2023, the good, the bad, and the ugly functions. Thank you.
Yeah, hi, I'm Marcel. My voice is a little bit broken, sorry for that. So hello and welcome to my talk. I'm being one of the admins running a platform on Kubernetes for containerized network functions since 2020. And we are now in 2023 and just want to give you some upsides and downsides of what we currently host. I'm Marcel, I'm located in Wesel, Germany. I think no one of you knows where that is. I'm pleasure coffee drinker and venturesome, and I do snowboarding in my free time and now gardening. So I'm getting better with the hedge skimmer in the backyard. So what was our mission when we started back then? So our mission was that we want to build a reliable Kubernetes cluster for our customers to run their workloads and be stable in our API contract. Then we also want telco-grade network integration for the functions to be able to run. And in the last thing we wanted to achieve is also contribute that back upstream so that others can make use of it or make it better and fix bugs. What is the story behind all of that? Running it on Kubernetes is not that easy. It is more like we want to put something very, very complex on something which was originally designed for web application hosting. So that was the first thing we needed to solve. And let's see why that is like it is. So this is currently a network function. They come in different shapes, in different virtualizations or not virtualized functions. And a simple network function in its own just exists of a control plane, which does the routing. For you, it's normally a routing daemon. And then you have the data plane, which does the work, which is not non-blocking. So normally everything we run is looking like that, just for different protocols, some different encapsulations and stuff. And normally the data plane should be non-blocking, so customers are not impacted by bottlenecks. Most of these functions are normally load balancers or firewalls or specific appliances to handset routing or stuff like that. And they evolved over time. So everything started with a PNF. It was a box you got shipped from the vendor. You put in your data center, plugged the correct cables and the correct ports, and then you're done. When something broke, you just call the vendor. And support and maintenance and also replacement was handled by the vendor. And then people thought that it's nice to just put it on a platform and don't have different hardware boxes in the data center. So they said, nice, we could virtualize it. So they made a whole standardization framework around virtualizing network functions and standardized it, and they called it then an NFVI, which was then a network function virtualization infrastructure, and mainly back then OpenStack was the way to go because it was cheap in comparison to other virtualization platforms. And that was the first approach to run it on a commodity hardware. And now we are in the newest era. They thought, oh, VMs are so big, huge, and it's not easy to schedule them, so let's put everything in containers. Deploy it with the 12 factors, And that is now the second approach to run network functions. And just, I made something up, so I called it now an NFCO, a network function and container orchestrator. This term doesn't exist, so, but yeah. So let's hibernate, sit back, and drink some VRFs, because they are needed to connect it. So first, you have normally a management VRF at the top, where your configuration comes from. And then, depending on the data plane, you have signaling VRFs or data VRFs, or also some encrypted VRFs, because the databases back then were not encrypted, so they said, oh, just put it somewhere else, which does the encryption for me. Yeah. So now let's have a look of how a good CNF should look like on our platform. So the black box is the host itself, and the blue one is the container. And we have one interface, which you all know, it's the ETH0 in the container network namespace. And it is connected to the default VRF, like a normal Kubernetes cluster works. Everything you do is in the default VRF on the Linux host. And in the ideal world, if they need fast data transmission, they should use something like an AFXDP socket or memory interface to get that fast data transmission on the hardware interfaces. Yeah. So what we invented, and there will be a talk later on, going into the details how we did that. We made it possible so that they can select what is connected where, and can also do route leaking on the Kubernetes cluster. So now what vendors ship when they come to us? It looks like this. So they just ported the VNF over to Kubernetes and said, now it's containerized. Yay. And please provide me a number of interfaces so that I can interconnect with your network. Yeah, this is a headache for us because we then needed to provide a lot of additional functionality to connect the function itself with all the different VRFs, and we can't rely on the standard Kubernetes tools. So what we needed was additional components, additional software parts, and it was not as simple to run those functions. And the most problematic part when they provide this is there's manual configuration on both sides to provide it. So we need to provide the interface and say, this is the gateway you need to use, this is the network you need to use, and they then need to manually configure it on their side so it works. That's not really how Kubernetes should work. It should just say, I need an additional network, and it should be there. Yeah. So now let's come to the conclusion. Vendors heavily like layer 2, and we try to enforce on them layer 3. We have a lot of problems, or had a lot of problems with Linux VRFs when doing route leaking. Also on that, later we will have a talk. And vendors really don't like the CNI approach of Kubernetes. We still don't know why. But yeah, they just use easier CNIs for them, like Mac VLAN or IP VLAN. And we should make them somehow standardizing around better interfaces, because they still rely on VNF technology here and use SIOV heavily. So we need to directly provide them hardware access on our bare metal clusters, which is not that nice. And we then have still complexity back in our network fabric. Yeah, to provide them a tagged VLAN interface for the fast data path. And they still love a lot of interfaces, and we think it comes from the 3GPP standardization, because it was standardized back then in LTE to use an interface per communication. But in 5G it was moved, but they still rely on it. the only safe haven we could have could be DPUs, but they are still in early phase and you can't buy them in a bulk. So normally you get 2 to 3 cards, and when you say I want 5,000, that's not possible. Yeah, that's my talk. Thank you.
Thanks, Marcel.